Hey guys, so in this video I'm going to talk about how to handle the missing values in some data, and I'm going to explain the concept first, the concept like how do we do the calculation, and then I'll go to Python as well, and we'll show you how do we do it in Python. So when we get the data to analyze, to process, the very first thing which I can say a very first challenge in front of us is the missing values in the data. So for example, if we have these three features, and I have not written the target here, I mean we don't uh, require as of now for this video. So if we have these three features and we have this here, this value missing and this value missing, then we have to, and right now I only have two values missing in two features, there might be more. So now this becomes a challenge for us to make sure that the values missing do not take away some information from here, from us, and we have to make sure that we have all the information, and we our analysis is meaningful, either without this data, or we have to impute this data, we have to replace the data with some meaningful data which basically doesn't affect our analysis. So one way usually people say, okay, let's uh, do away with this record, the full records which have missing values. But that is not valid if we have too much data missing in a lot of records. Like how long we can keep deleting the records, or maybe we can, one other way is we can just delete the feature, that particular feature, then again we can have missing value in all the features. So how long we can keep deleting the features? So we have to come with a logical way of replacing the value or get the value which might be missing, or a value close by, and there are certain ways to do it. So one of the very basic way is, which I'm going to basically emphasize on this video, is basically finding mean, median, mode of that particular feature and replace the blank with that value, then this NaN or whatever the missing value with that value. So for example, in this, for this feature, we can take the mean of uh, 10, 12, 16, 18. So if we take mean of 10, 12, 16, 18, what we are going to get, I'll just do the calculation. So maybe I'll do the calculations. Let me check. I'll take the mean of 10 plus 12 plus 16 plus 18. And then whatever I get, I divided by 4, because we have taken 4 numbers here, and the result would be somewhere around 30, and then we have 26, 56. So we have it around 14, I think, right? So 14 will be the mean. So I'll just replace this value with 14, right? And similarly, I can do here as well. Similarly, I can also take other, calculations like median. We can take mode, etc., etc. So, or we can have a constant value. Okay, let's take I just specify the value. Okay, let's replace all the NaN with 15, or let's replace all the NaN with 10. So we can do that as well. We can also do that differently for different features. For example, I want to replace all the NaN missing values for feature 2 by 10, and all the missing values for feature 3 by 12. So I can do that as well. So these things, this way of handling, imputing the missing value, is being done by Simple Imputer in machine learning in Python. So I'll show you that in this video, and there are other ways of imputing missing values as well. Like we have the way in which we basically regress, we use multiple or simple regression linear regression to impute the value. Sometimes we do the KNN, k nearest neighbors, in which we look at the nearest points and then we use those points to input the values. But I'll discuss all that stuff in uh, other next videos. In this, I'm going to simply discuss the simple imputer. So let's go to Python now. Okay, guys. So this is my Python, and I'm first of all I'm importing the regular packages OS, NumPy, Pandas. I'm importing Simple Imputer from sklearn.impute. So sklearn.impute is a class in sklearn for this purpose, and I'm imposing function Simple Imputer in this case from sklearn.impute import Simple Imputer. You can write this line as it is. Then of course I am here just changing my working directory to this directory, which usually I do it for for my surety that okay, the working directory is right what I want it to be. So then I am trying to read a file which is basically stored here in working directory missing values.csv. I'm trying to read this file and I'll show you what this file contains. This file contains all this stuff and they are missing values. I have put the missing values here. So I'm trying to read this file through pd.readcsv. I've already discussed this in previous videos that we can use this. Then I'm slicing certain values, certain columns, you can say certain features from this data in X. So df.ilog, I have already discussed this as well, that we can slice using this command. I'm slicing all the rows and then I'm slicing three columns, 1, 2, 3, right? So I'm slicing column this, and this, these three. This one is 0 column, then 1, 2, 3, right? And I'm also slicing 19th column, sorry. I'm also slicing 19th column uh, as target here. So although in this case I won't require it, but I'm just doing it. Then what I'll do, I'll just initialize this simple imputer and I'll say that missing values are np.nan. So consider them as np.nan. These are the missing values. In certain cases, we have to, when we have missing values by different name, we can replace those by a particular, np.nan or blank, whatever I want to do, right? So, and I can give one, either blank, either space or np.nan, whatever I want it to be, right? And yes, none or number can also be given. So either I can just, say my blank value would look like this, something like this, or something like this, whatever I want it to be. So in this case, I'm doing giving it nan, np.nan, right? And then I want to use the mean strategy in this case. So strategy is equal to mean. So we have these four strategies: mean, median, then most frequent, which we call mode as well, and then a constant, which I discussed. So I'll show you all these usages of all these strategies one by one. That's what I did. Then I basically replace all the data which is in there in X, which I sliced uh, from here, and I'll fit my this initialized function, which was initialized in impute.fit, and I'll also transform. So I'll just fit it here and I'll transform as well. So I can either fit, but a lot of times we fit in some other data set, then we transform some other data set based on the fit we did on the previous data set. But when we fit and change the same data set, then we can use fit underscore transform. So impute dot fit underscore transform, and then again I change all the data here in X. And again, since I am storing it in X only, so it will be replaced, right? And then I print X. So I'll run this and I'll see that first of all, I'll probably first of all maybe I'll just show you how my data looks like here, so that you can relate it to what we are trying to do. So when I run it here, and my data looks like this: NaN, NaNC. We have number of NaNs here, right? So now I have to, use my simple imputer, and when I do it, the same data will be replace. Remember NaN in the second place, then 1 2 3 4 fourth place, and now if I run this again, you will see that the same data is being replaced by the means. 13.47c is being replaced by the means. So wherever you can see this data with 3 decimal places, that is basically replaced, right? That's using mean. I can also use median here. If I use median here and I run it again, let's see what happens. So it's being replaced by the median now, right? So median here is 11, here median was 7, and accordingly it is being replaced. I can also replace this by most frequent data. I'll just copy it here. I use it here, and what I see is the data is replaced by the most frequent data, which is 4 in this case, 7 in this case, and accordingly, right? Now the last strategy is we can use constant. I want it to be constant. So what I'll do is, now if you see carefully, I'll just maybe show you first and then I'll explain. Let's say I want it to be 1, and let us run it again, and you'll see the change here. See, replaced by 1, right? Here replaced by 1. Remember, second data was missing here, right? And here it was 4 data missing, replaced by 1. See, yeah, 1 2 3 4 replaced by 1, right? Here it was second data missing, replaced by 1. So accordingly we can check. So there's one very important thing I wanted to mention, that for most frequent and for constant, we can also use these two for string data, for classification data. So here we had numeric data, we can also use it for string data if we want, and that will be the only thing is that the fill value should be string. So Python is very smart. So if you are trying to use most frequent or constant, and you using it on numeric data, but you want to give the fill value as a string, it will immediately identify and give an error. And same goes for string. If you working on string data, the text data, you're using most frequent or constant, and again, sorry, for string data you can definitely use numeric because it can take the number as string, but for number data you cannot use string, for imputation. So you have to use whatever number only, if the data type is number here. If you try to use string here, it will give an error, right? So yep, that's how you can do this. Then there's one more thing, that how to replace, how to make sure the or missing values are in same form. So I'll probably not discuss this in this video. I'll probably make a small video, another video, small video, for this, so that this video is not too long or is not too confusing. So basically here I am assuming all the missing values are represented by NaN, but sometime it can maybe represented by blank, sometime it may be represented by 0. So I'll tell you how to handle that. So as of now I'll just close this video. So thank you. Please comment if you have any other question you want to ask and you want me to answer, and I'll maybe add another small video for that particular question, so that your further doubts related to this are clear. Thank you.